For decades, the sight of missiles, cannons, and interceptor batteries sitting on the decks of aircraft carriers symbolized power at sea. But that era is fading quickly. A new type of weapon is emerging, one that can fire at the speed of light and cost almost nothing per shot while delivering devastating effects. Modern militaries are racing toward technology that can shrink the price of combat while multiplying lethality. Among all the platforms on Earth, only one class of ship can carry enough energy to make that vision real: the Ford-class supercarrier. Today we explore how this giant might reshape naval warfare and why lasers may soon redefine the battles of tomorrow. The Ford class did not appear overnight. Its story began under the CVN-21 program, a long-term plan to design the next generation of American supercarriers. The U.S. Navy requested initial funding in the early 2000s, and what followed was a development program unlike anything in maritime history. Construction of the first ship, the USS Gerald R. Ford CVN-78, officially began in 2007 at Newport News Shipbuilding. But the costs grew rapidly. The ship alone reached nearly $13 billion, and research and development added almost $5 billion more. Critics called it excessive. Supporters called it necessary. In the end, the result was a carrier unlike any ever built, a machine standing at the frontier of naval technology. When you see the Ford class in person, the scale barely feels real. With a displacement of around 100,000 tons and a flight deck longer than 3 football fields, the ship dominates the horizon. It carries close to 90 aircraft, from F/A-18 Super Hornets to F-35C stealth fighters, from Hawkeye early warning planes to Seahawk helicopters and advanced unmanned drones. The island superstructure has been moved farther aft, creating more usable deck space. The antennas are slimmer, smoother, and more modern. Everything about the ship looks like a leap forward from the Nimitz class that served before it. But the true revolution lies inside. Where the Nimitz carriers relied on energy systems designed in the 1960s, the Ford class is powered by 2 Bechtel A-1B nuclear reactors. They generate a staggering amount of electricity, around 600 megawatts. That is more than enough to power a small city, and it is exactly what a future laser carrier needs. The reactors are smaller, more efficient, and easier to maintain than the A4W reactors used on the older carriers. They feed 4 massive turbo generators that convert steam into electrical power, energy that fuels everything from propulsion to advanced sensors to the new electromagnetic catapult systems. The Electromagnetic Aircraft Launch System, called EMALS, replaces the old steam catapults used for generations. Instead of using steam pressure to blast an aircraft off the deck, EMALS uses a linear induction motor. It accelerates fighters and drones more smoothly, reducing stress on the airframe and extending lifespan. It eliminates the need for huge amounts of fresh water used for steam generation. It saves energy and speeds up launch cycles. On the other end of the landing process, the Advanced Arresting Gear System replaces hydraulic arresters with electromagnetic control. This gives pilots a safer, more predictable landing and allows the carrier to operate lightweight drones as easily as heavy fighters. One of the more complex challenges during construction was the Advanced Weapons Elevator Network. These elevators use electromagnetic motors to transport ammunition from deep within the ship to the flight deck. Their design ensures that weapons never cross into aircraft movement zones. That means faster rearming cycles, safer deck operations, and dramatically improved tempo during combat conditions. After years of adjustments and delays, the elevators began entering service one by one. Once fully operational, the Ford class can reload aircraft in minutes instead of hours. Sensors received an upgrade as well. The Ford class originally carried the dual-band radar, a combination of an X-band multifunction radar and an S-band volume search system. Although the futuristic Zumwalt-class destroyers for which it was originally designed proved too expensive, the radar itself found new life aboard the carriers. Later ships in the Ford series switched to the Enterprise Air Surveillance Radar, saving hundreds of millions of dollars and improving maintainability. Weapons mounted on the Ford class include evolved Sea Sparrow missiles, rolling airframe missiles, phalanx close-in weapon systems, and heavy-caliber machine guns. These defenses can counter a wide range of threats, but they face a new danger rising across the world: hypersonic missiles. China's DF-21D and DF-26 anti-ship missiles fly at speeds approaching Mach 10 and follow ballistic arc-like trajectories before plunging toward their targets. With ranges stretching beyond 1,000 miles, they create large zones of threat along coastlines. Intercepting them is extremely difficult. At such speeds, a tiny margin of error becomes fatal. Existing missile defenses may not react quickly enough. Which brings us back to the idea that is transforming military strategy: laser weapons. A laser beam moves at light speed, which means it can reach a target instantly. It does not need to predict where a missile will be halfway across the sky. It does not need costly interceptors or explosive warheads. A single shot might cost between $1 and $10, compared to tens of millions for traditional hypersonic interceptors. The contrast is stunning. For the price of a cup of tea, a laser could neutralize a threat that costs an enemy nation hundreds of millions to deploy. The most promising technology is the free electron laser, or FEL, a directed energy weapon with the potential to disrupt missiles, drones, and aircraft. The system works through precise detection. Radars identify an incoming object. The tracking system locks onto it, accounting for heat turbulence generated by hypersonic travel. Multiple beams are combined into a single intensified beam that strikes the target's weak points. Even if the missile is not vaporized, the heat can fry sensors, melt guidance fins, or compromise control software. A slight disruption in trajectory could render the missile harmless long before impact. Other defense systems can finish the job if necessary. Among the candidates for deployment on the Ford class, Helios stands out. This high-energy laser system developed by Lockheed Martin produces a beam of 300 kilowatts. It can blind hostile sensors, disable drones, and burn through thin-skinned missiles. To evolve into a full hypersonic interceptor, Helios will need power levels closer to 500 kilowatts or even a megawatt. The atmosphere reduces energy as the beam travels, so wavelength and power adjustments are critical. But if any ship can support that scale of energy, it is the Ford class with its massive nuclear reactors and abundant reserve power. Integration is another advantage. Helios can connect with the Aegis combat system and the Spy 6 radar on escorts. Combined with the carrier strike group's layered defenses, a laser-equipped Ford becomes the centerpiece of a new form of naval warfare. 10 years ago, the Navy tested a 40-kilowatt laser on the USS Ponce, successfully destroying drones and small boats. More recently, the Arleigh Burke-class destroyer USS Preble tested Helios against unmanned aerial targets. The system performed effectively, giving a hint of what future weapons might achieve. What remains is the leap from destroyers to supercarriers. When the first full-power combat laser is mounted aboard a Ford-class carrier, the nature of naval defense could shift for decades. Hypersonic threats may lose their advantage. The cost of interception may plummet. Carrier strike groups could operate in contested zones with confidence once thought impossible. The question is no longer whether lasers will enter military service, but when and where their full potential will first be demonstrated. The Ford class, with its unprecedented energy reserves and advanced systems, is positioned to become the first true laser carrier in history. As militaries shape the future, one thing is clear: warfare is entering a new chapter, not defined by explosions, smoke, and debris, but by invisible beams of concentrated energy that strike in silence and move faster than anything humanity has ever built. Whether this shift creates more stability or sparks new competitions remains to be seen. But the future is here, and the Ford class stands ready for whatever comes next.